Okay, we got to this point. I said, okay, S of 0 equals 0, and thought there was something wrong with that because, as often happens, I'm thinking in terms of velocity even though I'm writing S. Okay, somewhat distracted. S of 0 equals 0 is exactly what we expect. That's our starting position. It's a perfectly valid starting position. It's not a valid starting velocity, but this is perfectly okay. V naught equals 2 meters per second. So that, and also S at 5 seconds equals 4 meters. Well, S of 5 seconds equals 4 meters. So S of 5 seconds with our S of t function, and this is an absolute value sign here, not part of the boundary of this region of the board, gives us this. And we would need to solve this for delta. So how do we solve this for delta? Well, it might be instructive to graph S versus t. We could. It's going to be very much, as t gets large, like the graph of, if t is large, not 5 seconds, but a large number, then this number is a lot bigger than 1, and the 1 doesn't make much difference. So it's pretty much then the natural log of delta V naught over m times t. We can ignore the 1 that we get from m over m, this over m. Okay? Still, we would have something like m over delta, and that's a badly written delta, but that's supposed to be a delta, times that natural log. And of course, the natural log of delta V naught t is the same as the natural log of t raised, the natural log of t raised to the power delta V naught. So we have this. Now we have a delta up here in the exponent and the delta down here and a denominator of something completely different. It's going to be impossible to come up with a closed form solution for delta. So we can take this, we have some confidence in this, but let's go over here now to an analysis of our velocity. Okay? Velocity at 5 seconds is supposed to be undetectable, or at least very small. So I'm going to make the assumption that our velocity at 5 seconds is less than 1/10 of a meter per second. Okay, just an arbitrary, slow movement. Okay, and actually when I observed this, I couldn't verify that I wasn't moving at 10 centimeters per second. Actually, I probably could. I was moving slower than that. But that's not an implausible result. Okay, so if velocity at 5 seconds, well, we take our velocity function, we plug our numbers in here, and everything but delta has a number on it. So here's the inequality. Okay, this has to be less than 0.1 meter per second. Now, I believe if you, and I just did this intuitively, well, not so much intuitively, this is going to be 10, and multiplied by delta, and then divided into 150 has got to give us something less than 0.1, which means this denominator has to be at least 1,500. And the units, of course, need to be checked, but they work out. Well, if this has got to be at least 1,500, then this has to be at least 1,425. So, something happened on the screen there. So, that means